So, good morning. Myself, Dr. Lingaraju, Assistant Professor, Government Fascia Degree College, Tumkur. Our college is affiliated to Tumkur University. So, today we will discuss in Diffraction chapter some problems. So, we are already discussed in the Diffraction chapter so many theoretical concepts. Based on that, so we will discuss here some problems. These concepts will be comes in BSc Physics 4th semester. This problem discussion is we called as a session 39. So here what we are going to discuss the problems. All these things are covers in the previous theory concepts. If you know the basic concepts of a theory subject, so you can easily identify, recognize the required formulas. So if you know the formulas, we can substitute and get the answers. So that is next step is very simple. So first we will discuss what are the problems. If you know the basic ideas about a particular concept, we can easily recognize or identify, and also we can understand the problem and recognize the formula. So knowing that way, so first we will discuss the problem. First problem, a straight edge is at a distance of 2 meters from a narrow slit illuminated with a light of wavelength 6000 angstrom. A screen is placed at a distance of 2 meters from the straight edge. Find the distance between the first and fifth dark fringe, the diffraction pattern on the screen. So in the last previous class we discussed a little bit similar type of a problem. So here the given data says a straight edge at a distance that is A is equal to 2 meters. Our narrow illuminated a wavelength of 6000 angstrom, that is wavelength 6000 to the power of minus 2. If a screen is placed at a distance that is B is equal to 2 meters from the straight edge, find the distance between the first and fifth dark fringes in the diffraction pattern. First and fifth dark fringe is the diffraction pattern, that is x1, xy. After knowing these two, find out the differences xy minus x1. We know the formulas. Xn is equal to square root of 2n of a plus b of b lambda by a. The first dark fringe, that is n is equal to 1. The fifth dark fringe is n is equal to 5. So like that. First dark fringe n is equal to 1. On substituting n is equal to 1 in xn, we arrive at the required answer x1 is equal to 1.8973 into the power of minus 5 meter. Next, for a fifth dark fringe n is equal to 5, on substituting n is equal to 5. So xn is arrived at the required of x5 is equal to 6.48 into the power of minus 3 meter. So knowing these two things, so subtract the distance between the fifth and first dark fringe, x5 minus x1, that is equal to 4.5827 into the power of minus 3 meter. So the distance between the fifth and the first dark fringe is 4.5227 minus 6. So the substitutions of these two. ನೋಡಿ ಎಷ್ಟು ಈಸಿ ಇದೆ. ಫಸ್ಟ್ ನಮಗೆ ಇದರ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಗೊತ್ತಾಯಿತು ಅಂತಂದರೆ ಆ ಡಾರ್ಕ್ ಫ್ರಿಂಜಸ್ ಇರೋಲ್ಲ, ಫಸ್ಟ್ ಡಾರ್ಕ್, ಸೆಕೆಂಡ್ ಡಾರ್ಕ್, ಥರ್ಡ್ ಡಾರ್ಕ್, ಫೋರ್ತ್ ಡಾರ್ಕ್, ಫಸ್ಟಿಂದ ಫಿಫ್ತಿಗೆ ಎಷ್ಟು ಡಿಫ್ರೆನ್ಸ್ ಇದೆ. ಸೊ ನ್ಯೂಟನ್ಸ್ ರಿಂಗಲ್ಲಿ ಬರುತ್ತೆ, ಅದು ನೋಡಿರ್ತೀವಿ ನಾವು ಲ್ಯಾಬಲ್ಲಿ ಮಾಡ್ಬೇಕಾದ್ರೆ. ಸೊ ಅದನ್ನು ನೀವು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡು ಹ್ಯಾವ್ ಟು ಅನಲೈಸ್. ನೆಕ್ಸ್ಟ್ ವಿ ಗೋ ಟು ದ ಸೆಕೆಂಡ್ ಪ್ರಾಬ್ಲಮ್. ಈಗ ಎರಡನೇದು. In an experiment with a straight edge diffraction, the distance between the slit and the edge is 1.2 meter, and that between the edge and the screen is 1.8 meter. If the wavelength of the light used is 600 nanometer, find the distance between the first and third bright fringes. So A is equal to 1.2 meter, B is equal to ಎಷ್ಟಿದೆ 1.8 ಮೀಟರ್ ಇದೆ. ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಎಷ್ಟಿದೆ 600 ನ್ಯಾನೋಮೀಟರ್ ಇದೆ, ಅಂದರೆ 600 -9 ಮೀಟರ್ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಏನು ಕಂಡುಹಿಡಿಯಬೇಕು, ಫೈಂಡ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಫಸ್ಟ್ ಅಂಡ್ ಥರ್ಡ್. x1 is equal to how much, x3 is equal to how much, and also difference, that is x3 minus x1 is equal to how much. Similar type of a previous problem. The position of nth bright fringe is given by xn is equal to square root of 2n plus 1 of a plus b of b lambda by a. So ಅಲ್ಲಿಗೆ ಫಸ್ಟ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಅಂದರೆ n is equal to 1 ಆಯಿತು. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್, 2 ಗೆ n, a, b, ಲ್ಯಾಂಬ್ಡಾ, ಅವಾಗ ಸೊ n is equal to 1 ಆಗಿರುತ್ತೆ. ಇಲ್ಲಿ n is equal to 1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ we get x1, x is equal to 1 ಅಂದರೆ 28.4 × 10 - 4 ಮೀಟರ್. ನೆಕ್ಸ್ಟ್ ಅದೇ ಥರ ಥರ್ಡ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಬರೋಣ. ಥರ್ಡ್ಗೆ ದ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಥರ್ಡ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್, ಫಿಫ್ತ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಪ್ರಿಂಟಿಂಗ್ ಸಿಕ್ಕಿದೆ. ಥರ್ಡ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ n is equal to 3. On substituting n is equal to 3, xn we get x3 is equal to 43.47 × 10 -2. Previous ಎಷ್ಟು ಬಂತು, ಸೊ 28, ಇದೆಷ್ಟು ಬಂತು 43. Then separate between third and first. So the separate between the third and first fringes x3 minus x1 is equal to 15.01 × 4 meter. So the distance between the third and first dark fringe is 15.01 × 4 meter. So it's about the problem of first and first dark fringe difference. Next we come to the third problem. The radius of the first zone is in a zone plate is 0.5 meter for a source of light of wavelength 541.6 nanometer, which is placed at a distance of 1.8 meter from the plate. Calculate the position of the image of the source. Focal length of the equivalent lens has the same effect as that of the given zone plate. ಇವೆರಡು ಕಂಡುಹಿಡಿಯಬೇಕು. ಯಾವುದು ಪೊಸಿಷನ್ ಆಫ್ ದಿ ಇಮೇಜು ಮತ್ತು ಸೋರ್ಸ್ದು, ಆಮೇಲೆ ಫೋಕಲ್ ಲೆಂತ್ ಆಫ್ ದಿ ಈಕ್ವಲ್ ಲೆನ್ಸ್, ದ ಸೇಮ್ ಎಫೆಕ್ಟ್, ಇವೆರಡು ಕಂಡುಹಿಡಿಯಬೇಕು. ಸೊ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಗಿವನ್ R1. ಸೊ R1 is given, that is 0.5 0.05 meter, n is equal to 1, ಫಸ್ಟ್ ಝೋನ್ ಪ್ಲೇಟ್ ಆಗಿರೋದ್ರಿಂದ. ಸೊ ಲ್ಯಾಂಬ್ಡಾ is equal to 541 in nanometer, u is equal to 1.8 meter. So to find f is equal to how much, v is equal to how much. So focal length of the zone plate is given by fn is equal to rn square by n lambda. So n is equal to 1. On substituting the n is equal to 1 value, fn we get f1 is equal to r1 square by 1 into lambda. So substitute all these things, we get the 4.61 into the power of -3 meter. So it's about third problem. Next here we come to the fourth problem. So second way, v value ಕಂಡುಹಿಡಿಯಬೇಕು. Next we have 1 by f is equal to minus of 1 by u plus 1 by v. Substitute the above equations, equating towards 1 by v. 1 by v is equal to 0.55021. So v is equal to 1.81 meter. V is equal to 1.81 meter. Next we come to the fourth one. In Fraunhofer diffraction, due to a narrow slit, a screen is placed 1.8 meter away from the lens to obtain diffraction pattern. If the slit width is 0.3 millimeter and the first minima lie 6 millimeter on the either side of the central maxima, find the wavelength of light. Find the wavelength of light. Solution. So ಇಲ್ಲಿ ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಫಸ್ಟ್ ರೈಟ್ ದ ಗಿವನ್ ಡೇಟಾಸ್. ಎ ಕೊಟ್ಟಿದ್ದಾರೆ, ಏನದು? ಸೊ ಸ್ಲಿಟ್ ವಿಡ್ತ್ 0.3 millimeter ಅಂದರೆ 10⁻³ ಮೀಟರ್. ನೆಕ್ಸ್ಟು ಸೊ ಫಸ್ಟ್ ಮಿನಿಮಮ್ ಎಷ್ಟಿತ್ತು ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ದಟ್ ಈಸ್ x = 6 × 10⁻³ ಮೀಟರ್. ಆಮೇಲೆ ನೆಕ್ಸ್ಟು ಸೊ ನ್ಯಾರೋ ಸ್ಲಿಟ್ ಆಫ್ ಎ ಸ್ಕ್ರೀನ್ ಪ್ಲೇಸ್ಡ್ ಫ್ರಮ್ ದಿ ಸೋರ್ಸ್ ಅದೆಷ್ಟಿದೆ, 1.8 ಮೀಟರ್. ಸೊ knowing this one, calculate the lambda. So the diffraction minima A sin theta is equal to L lambda, the formula. So in the first minimum n is equal to 1 ಅವಾಗ ಏನಾಗುತ್ತೆ, A sin theta is equal to lambda ಆಯ್ತು. So sin theta is equal to lambda by A. For the diffraction, sin theta is equal to, so lambda is for a diffraction x by d ಆಯ್ತು. By comparing the above equations, x by d is equal to A lambda by A. In the resolving power of microscope, we are going to carry using this concept. Lambda is equal to Ax by D. On substituting the given data, we arrive at the required answer. Lambda is equal to 1 × 10⁻⁻6 meters. This is a wavelength. Next, here we come to the fifth problem. Zones are marked on a zone plate which has a diameter of 1 centimeter. ಈಗ ಒಂದು ಝೋನ್ ಪ್ಲೇಟಲ್ಲಿ ಮಾರ್ಕ್ ಮಾಡೋದು, ಅದು ಡಯಾಮೀಟರ್ 1 centimeter ಇರುತ್ತೆ. ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ಫೋಕಲ್ ಲೆಂತ್ ಫಾರ್ ಲೈಟ್. ಆ ವೇವ್ ಲೆಂತ್ 580 ನ್ಯಾನೋಮೀಟರ್. ಎಫ್ ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿಯಬೇಕು ಯೂಸಿಂಗ್ ಎ ವೇವ್ ಲೆಂತ್ 580 ನ್ಯಾನೋಮೀಟರ್. ಸೊ ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ಗಿವನ್ ಡೇಟಾಸ್, ಫಸ್ಟ್ ಹಿಯರ್ ವಿ ಆರ್ ಟ್ರೈ ಇಟ್. n is equal to 50 are marked on the zone plate. Zones are marked on a zone plate, that is a 50. Next, d of 50 is equal to 1 centimeter. So that is 1 × 10⁻² meter. R of 50 is equal to d by 2, that is equal to 1/2 × 10⁻². So that is also we can write it 0.5 × 10⁻³ So lambda ಎಷ್ಟಿದೆ, 5809 × 9, 580 × 10⁻⁹. So knowing this, find f is equal to 1. We have f is equal to r square by 50 by n lambda. On substituting given data, we have a required answer. F is equal to 0.86 meter. So next problem, sixth one. A narrow slit is illuminated with a monochromatic light of wavelength 5893 × 10⁻⁻10 meter. Is placed at a distance of 0.1 meter from a straight edge. If the distance between the straight edge and the screen is 1.9 meter, calculate the distance between the first and fourth dark fringes. So same type of problems already we discussed. So let us see how much. The lambda is given, that is 5893 × 10⁻⁻10. A is equal to 0.1 meter. B is equal to 1.9 meter. Then to find x1 and x4, then difference of x4 minus x1. So we know that xn is equal to square root of 2n of a plus b, b lambda by a. So for a first dark fringe, n is equal to 1. So x1 is equal to n is equal to 1 ಹಾಕಿದ್ರೆ x1 ಅವಾಗ 6.69 × 10⁻³ meter ಅಂತ ಬರುತ್ತೆ. So for a fourth dark fringe, n is equal to 4, x2 is equal to, if calculating the previous formula using this formula, so 2n of a plus b of bn by a. ಅವಾಗ ನಮಗೆ x1 6.69, if n is equal to 1, if n is equal to 4, x4 is equal to 13.3 × 10⁻³ meter. ಆವಾಗ ನಮಗೆ x1 ಮತ್ತು x4 ಗೊತ್ತಾಗಂದ್ರೆ the distance between fourth and first dark band is given by the difference x4 minus x1 is equal to You are defined with 6.67 into 10 to the power minus 3 meter. So the distance between the fourth and first dark point is the value 6.67 into 10 to the power minus 3 meters. So knowing this one, next year we come to the one other problem. Calculate the highest order spectrum of normal incidence which may be seen with a monochromatic light of wavelength 6000 into 10 to the power minus 10 meter by means of diffraction grating having a 6 10 to the power minus 10 per meter. So knowing this one, 6000 into 10 to the power minus 10 meter, n is equal to 6 into 10 to the power minus 5 lines per meter. ಈ ಒಂದು ಡಿಫ್ರಾಕ್ಷನ್ ರೇಟಿಂಗ್ ಅಲ್ಲಿ ಸೊ ಒಂದು ಮೀಟರ್ಗೆ ನೋಡಿ 6 into 10 to the power plus 5 ಅಂದರೆ ಅಷ್ಟು ಲೈನ್ಸ್ಗಳು ಸೊ 1 ಮೀಟರ್ ಒಳಗಡೆ ಲೈನ್ ಹಿಡಿದಿದ್ದಾರೆ ಅಂದರೆ ದಟ್ ಈಸ್ ಇನ್ ಡಿಫ್ರಾಕ್ಷನ್ ಗ್ರೇಟಿಂಗ್ ಅಲ್ಲಿ. ದಟ್ ಈಸ್ ಡಿಫ್ರಾಕ್ಷನ್ ಗ್ರೇಟಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಅಂತ ಕರಿತೀವಿ. ಆಮೇಲೆ ಸೊ ಡಿಫ್ರಾಕ್ಷನ್ ಗ್ರೇಟಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಈಕ್ವೇಶನ್ ಏನಿರುತ್ತೆ, a plus b of sin theta n is equal to n lambda. The maximum value of sin theta n is equal to 1. So a plus b is equal to n lambda. So a plus b is equal to 1 by n is equal to 1 by 6 into 10 to the power 5 meter. So ಈಗ ನಮಗೆ 1 by 6 into 10 to the power plus 5 is equal to n ಅಂತ ಬರ್ಕೊಂಡ್ರೆ into so equate 6000 into 10 to the power minus 10. Then it becomes to n into 6 power 10 to the power minus 7. Then n is becomes to, equating all these things, 1 by 6 into 10 to the power plus 5 into 6 into 10 to the power minus 7. So substitute this value is the value 1 by 36 into the power minus 2. So that is equal to 100 by 36. So it is equal to 2.77. 2.77 upper limit of contra, we can say approximately equal to 3. Hence higher order of the spectrum is 3. So like that here we can give the conclusions of this problem. So next problem, that is 8th problem and also last problem of this session. A plane transmission grating having a 6000 lines per centimeter is used to obtain the spectrum of a light from a sodium lamp. In a second order, calculate the angular separation between the two sodium lines whose wavelength is 5892 and 5896. So n is equal to 6000 lines per centimeter ಇರತಕ್ಕಂಥ ಒಂದು ಇದೆ ನಮ್ಮ ಹತ್ರ ಏನು ಗ್ರೇಟಿಂಗ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ 6000 ಲೈನ್ಸ್ ಇದೆ. ಸೊ ಇದನ್ನ ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಲ್ಯಾಂಬ್ಡಾವನ್ನು 5890 into the power minus 10, lambda 2 so 5896 into the power minus 10. To find theta 1 theta 2, then d theta is equal to theta 1 minus theta 2 difference. The required formula is a plus b is equal to 1 by n. That is equal to 1 by 6000 into the power minus 2. That is also equal to 0.166 into the power minus 5. For second order, n is equal to 2. For the diffraction grating, a plus b of sin theta n is equal to n lambda. If n is equal to 1, then a plus b of sin theta 1 is equal to n lambda. Sin theta 1 is equal to 2 lambda by a plus b. On substituting, we arrive at the required value. Sin theta 1 is equal to 0.7098. So that is approximately sin inverse of this value is equal to 45.21. So this 45.21 is the theta 1 values. So knowing this theta 1 value, we can calculate. We got it the values. That is another. So angular separations of a grating plates using a two monochromatic wave cells. So we discussed all these problems using our diffraction pattern concepts. So these problems are I referred through a Sundarajan textbook. Sir has given a college physics book in United Publishers, and also Subramaniam sir is also a very good book is written. The name of the book is the Textbook of Optics, and also they are published in Chand Publishings. So and remaining Mangal Gauri, third, fourth one Nagbhushan H, fifth one Ramakrishna So all the teachers are written books as per the guidelines of prescribed textbook of Tumkur University Physics. So I have also referred so many different concepts using a website and also remaining other things. So it's about our references of the books. Just go through this kind of a textbook problems, and also will give you some problems. So you take these problems, think it about a particular problems, find out the given data, and also calculate the required answers. So it helps for your main examination also. So it's about the diffraction pattern concepts. Thank you.